So at the moment, show IP BGP summary says that the state is active, but we don't have a established neighbor relationship. Show IP BGP neighbor shows us that we have a neighbor relationship configured to 17.17.17.2. Remote autonomous system is 17. The router realizes that this is an iBGP connection or internal connection because both autonomous system numbers are the same. The local autonomous system is 17 and the remote autonomous system is 17. BGP version is 4. Remote ID hasn't been learnt yet because a connection hasn't been made and established. So, show IP route. We have no route to this IP address. So conft router OSPF1. We are going to run OSPF internally within our autonomous system to allow router 1 and router 2 to communicate with each other. So network. And I'll just enable OSPF on all interfaces on this router. So network 0000, 255.255.255.255, area 0. Notice the difference. Show IP OSPF interface. IGPs such as OSPF run on interfaces. In other words, they are enabled on interfaces. OSPF runs at layer 3 or layer 4, depending how you want to argue it, of the OSI model. So notice it's running on interfaces on this router. BGP, however, does not run on interfaces. So using the command show IP BGP interface, we can see that we have an address family for unicast, in other words IP version 4 unicast addresses, but it's not running on any specific interface. Here's IP version 6 unicast. And scrolling down, here's VPN v4, which is used in multi-protocol MPLS environments. So once again, the difference is that OSPF or other IGPs are enabled on interfaces. BGP is not enabled on interfaces. BGP runs at layer 7 of the OSI model. You have to manually configure the neighbor relationships, whereas a IGP, such as OSPF or EIGRP, will automatically form neighbor relationships with one another. And we can see that when I enable OSPF on router 2. So on router 2, I'm only going to enable OSPF on network 17. I don't want to advertise OSPF to the internet. So I'm not enabling OSPF on network 8 or network 4. In other words, not on our internet-facing interfaces. Show IP OSPF interface brief. OSPF is enabled on the loopback interface and the fast Ethernet 0.0 interface, and a neighbor relationship was formed between router 1 and router 2. So show IP OSPF neighbor. Notice the neighbor relationship was automatically configured, but in BGP it's not going to work that way. So let's see what happens when we configure BGP. So firstly, show IP BGP summary. Neighbor relationship is still active, which means it's not working. Can this router ping the loopback of router 2? Yes, it can. So notice now when I telnet to the loopback of router 2, I get a message saying that password is required but none is set. But I am able to telnet to the loopback of router 2 because that route is in the routing table of the local router. But the BGP relationship is still not configured. So let's configure the BGP relationship on router 2. So router BGP 17, neighbor 17.17.17.1, remote AS is 17. Show IP BGP summary. Relationship is showing as idle. On this side, show IP BGP summary, showing as active. The relationship is not working, however, and the reason for that is the following. Show run section BGP. This is showing us the BGP configuration. We typed router BGP 17 and then specified a neighbor. These other commands are default commands. So as an example, BGP will not automatically summarize routes because of the no order summary command. The issue here is when you telnet to, for instance, a remote device, the source IP address is going to be the outgoing IP address by default. So as an example, debug IP packet will show us that when I telnet to the loopback of router 2, we get some output. I'll turn that debug off. What I'd like you to see in the debug is the source IP address is 17.1.1.1, this IP address, for the telnet traffic to the loopback of router 2. By default, when you initiate a session from a router or send traffic from a router, it uses the outgoing IP address as the source IP address of the packets. Router 2, however, hasn't been configured with a neighbor of 17.1.1.1. The neighbor relationship is 17.17.17.1. So the rule is, if I don't want to form a neighbor relationship with you, you cannot automatically initiate a relationship with me. Both sides have to agree to form the neighbor relationship. Just because router 1 is configured with the neighbor relationship of router 2, it doesn't mean that router 2 will accept the neighbor relationship from router 1. When router 1 is sending BGP packets to router 2, it's using this IP address rather than this IP address. So router 2 rejects it. And in the same way, when router 2 sends BGP packets to router 1, it's sending them from this IP address. Router 1 rejects that IP address because it expects the packets to come from this IP address. So what we need to do is go into BGP and say neighbor and the specific neighbor that we want to configure. And we have to specify the update source being loopback 0. We have to tell router 2 that when it sends packets to router 1 using BGP, that it use this IP address as the source. So the neighbor relationship went up, but it's not going to work fully yet because we have to do the same thing on router 1. So we have to say neighbor 17.17.1 update source loopback 0. And I put the wrong IP address in there. 17.17.2 update source loopback 0. Show IP BGP summary. Notice the state is blank. That's a misleading command in BGP. That means that the neighbor relationship is established. Notice the uptime in this case is 44 seconds. At the time when I typed this command, it was up for 35 seconds. We can see what's actually happening by typing show IP BGP neighbor. And for our specific neighbor, so there's the command. Here's the neighbor 17.17.2. We can see that the relationship is established. That's what we're looking for. Established means that the neighbor relationships are working or are configured. But unlike other routing protocols, notice at the moment no prefixes have been received from the neighbor. In other words, router 2 and router 1 are learning no networks from each other. Just because you configured BGP doesn't mean that networks are going to automatically be advertised. You have to either redistribute routes into BGP or manually advertise them into BGP. So now that our neighbor relationships are configured, we need to advertise routes into BGP.